Hi, everyone. Welcome back to ProjectPro Expert Talks. We are honored to have Santosh with us here. He spent over 14 years as a data scientist, starting off earlier with Microsoft and then Hotstar, Myntra, and currently with Policy Bazaar, which is probably Asia's largest online insurance marketplace. Santosh, thank you very much for your time.
Thank you, Vinny.
So Santosh, one of the things I was curious about is I noticed that you have built teams across both data science and big data. One of the things we're curious about is people are always confused upon how do these teams interact with each other? When do these projects get handed off? Would love to hear your thoughts on that.
Okay, so the answer is not very straightforward in the sense that it actually depends on the organization, right? And depends on how the technology team is actually structured. Like, I mean, in certain companies, you actually have a big data team, like essentially the data engineering team. In certain companies, it is clubbed with the data sciences team. Very rarely have seen that. But like, in my previous couple of organizations, because we were starting off the data sciences practice as well, and which also needed a lot of data, so we kind of clubbed them together. But data engineering is by and large mostly a different team altogether, right? Having said that, the data sciences team will invariably require some data engineers, or essentially some application engineers, whatever you want to call them. But basically, you will need some engineers simply because the data sciences, essentially the data scientists, what they do is they actually work on complicated open-ended problems. Right, something that you cannot completely solve with engineering, right? I mean, with the traditional engineering tools. So, but I've seen the data scientists are mostly the research types where they find solutions, but they don't necessarily know how to productionize it. Although that's kind of changing, the entire landscape is also changing in that sense. So you have machine learning engineers now coming into the fold, but by and large, that's kind of been the norm, right? Like they do proof of concept solutions, and then the data, basically the engineering guys are taking this to production. The other thing that the data engineering, the big data guys in particular, do is actually they build those scalable, robust pipelines, whether it's for training or it's for basically deployment, or essentially kind of scoring the models in runtime, and a variety of things that that happen there, right? So when does the handover happen? Again, it depends on the use case, but by and large, data engineering does give the input to the data scientists when they're building the models and then productionizing them as such. These are two areas, but the data engineering guys also have a much larger kind of canvas to work upon.
Okay, and due to the strong interaction and coordination, do one set of these people need to start learning skills that the other side needs? If so, who should start learning what skills on the other side?
Great question. So I think both of them need to understand basically skills of the other domain. For a data engineering guy who doesn't necessarily want to get into, for example, I'll take an example. So if there is a large scale time series kind of a product that solution that you're deploying, the data engineering guy needs to know essentially some bit about what the model does. What are the inputs? What are the outputs? How do I actually, on a large scale system, how do I actually check for issues that might come up in the data? Right. So he does need to know how, in general, some of those models work. What are the inputs and what are the outputs? Now, for the data scientist, yes, he is. He's also expected to know about how, what are the sources of data? How is it actually getting ingested? If at all there are going to be issues with the data, how do I handle that? So, actually, what again, as I said, right, this whole world is changing at such a rapid pace. The data scientists are now actually looking at some part of the engineering stuff as well. So I do find that actually it's getting mixed in some ways.
Okay, great, very helpful. And the other thing I was curious about, Santosh, is that through your career, you've been in a couple of very interesting cutting-edge industries like e-commerce, entertainment, digital marketing, and insurance right now. What aspects of the problems and the tools and the techniques change across these industries, and what aspects stay the same?
Okay, so see, I mean, actually, different industry. I mean, the industries may change, the problem sets change, right? The scale changes. But by and large, if you look at the nature of the problem, I mean, at least the solutions or the techniques, even those are evolving. I mean, as we speak. But basically, they are kind of similar in the sense. If you know what I mean. What I mean by that is, some of those standard machine learning techniques don't change. Right. So deep learning, sure, there is a lot of research going on, particularly in the natural language space and all of that stuff. It's changing. I mean, actually, there's a lot more research coming out. But by and large, the tools remain the same. I don't think they are changing very rapidly. If you're curious enough to kind of take, if you're knowledgeable about some of the areas that you've actually worked upon, looking at the problem and understanding what needs to be solved and how to solve them is what comes across, right? I mean, across different industries. Now the key difference between different industries is, as I said, like for example, like personalization. I'll take an example of personalization, right? Personalization in an e-commerce industry is very different from basically what you would see on a Hotstar, for example, like the entertainment, right? Again, within personalization, or for that matter, even the current company where I work, basically Policy Bazaar, because it's a different domain, and the customer expectations are also, customer journeys on our portal is going to be very different, right? The intent is going to be very different, right? So some of the problems change actually, if you think about it, right? The way you're going to solve. And one interesting aspect that comes in is like when you're actually building a product, invariably what happens is data scientists, I mean, the way I associate data scientists is they're actually building products, right? I mean, in a technology company. Of course, there are different variants of data scientists. Basically somebody could be actually solving really complicated business problems, but they don't necessarily build products. There are many people like that. But if you're looking at the technology world, it depends on the scale. Now, why is the scale important? Because building one solution from something else is dependent on the scale, right? So I hope I've answered that.
You have,
I mean, tools are pretty much the same, but the way you approach the problems are different.
And when you're trying to hire for roles to tackle these different kinds of problems, what are those top 2 or 3 filters you look for in these interviews?
So, so it depends on the level of hiring. Now, I actually believe that, some of the youngsters, the freshers who are getting out of college are pretty good. They're pretty talented as well. And then you obviously are looking at a different skill set from an experienced person. Now, let's say you are hiring for a sort of, for an experienced position or a role. You would expect that person to have done something which is very relevant to what you're actually solving for, right? And again, there are many flavors, as I said, right, of data scientists. So I might actually, for some of the problems that we are handling at Policy Bazaar, I would actually look at a senior person who's actually done quite a bit of stuff on the natural language side, right? So somebody who's done research, who's open, who's open to actually doing open-ended research.
Okay.
Right. So that's one kind of a profile, and then you've got the second kind of a profile, even in the experienced one, where the guy, he's done that, but he's also, he's also built a few products, which means there is, he knows technologies, he knows how to kind of build it from scratch. That's the other kind of profile that I would look at. Okay. From a fresher's perspective, I look at few things. In fact, across the board, a few things which kind of are common is, one is basic understanding of the algorithms, right? If he's put it in the resume, if it's a complete new fresher, then I would look at the kind of projects he's done and the interest is shown in, say, machine learning or artificial intelligence, and then hopefully he should be able to demonstrate that. Familiarity with the algorithms, good sound knowledge of mathematics, at least the basic ones, right? Some calculus, some linear algebra does help, right? And it is helpful. right? I mean, so the point I'm trying to make here is, today you've got a lot of these, I mean, all the big players giving you APIs out of the box, right? I mean, on cloud. It helps you to an extent. Like a business analyst, it does help you. But where does the data scientist play a role? It's from, I mean, when you take those solutions, you deploy them, you get 50, 60, 70% accuracy. What about after that?
Yeah.
Right. That's where it, people hire a data scientist, right?
Point,
I mean, so now there you need maths, right? You need to know what is going on behind the algorithms. What can I actually change, right? The third thing which I would look at is the problem solving. For example, and here is what happens, right? I typically start with a case study and think about it, right, Bini? There are problems. I mean, if I just turn around the room, I can actually find hundreds of problems related to machine learning which I could solve, right? So I could ask that guy, saying that, like, why don't you just look around and tell me what can you solve? Yeah. What are the data points that you would need? How would you solve it? Right? The structured approach to any problem solving is what I basically look at. And finally, but not the least, actually coding skills. That's like the bare minimum. It's hygiene. Right. So
okay.
And a few other things, right? Like if people, particularly the freshers or people with 1 or 2 years of experience, I would like to see something different on their resume, right? When you're actually getting into an interview. Like, for example, sure, a lot of people do go through Kaggle, they solve some of the problems. Can you actually post a website of all the projects and, like, you've done? You have a GitHub repo, associated with you. Can you showcase some of the things that you've done?
Like a portfolio.
Really, yes.
And once they go through the interviews and they join and they're working on these projects, are there any of your favorite hacks or tactics or best practices to get these data science projects done efficiently?
It's a very how do I say? It's a great question. I don't think there is a how do I say? There is no best practices. If I were to kind of put down the best practices, I think you need to look at how you are basically, getting the data. Now, if you're, like, for example, I mean, I think that's more to do with my profile, in the sense, like, think about the overall architecture. But in the sense that if I'm trying to solve 10 problems with the same set of data, can I actually build something which makes it makes my job or a data scientist job much faster, right? So that's something basically. The second best practices would be that if I've done some bit of work, can I reuse it elsewhere, right? I mean, there are common set of problems that come across with a little bit of tweaking. So those, it's invariably related to the data and some of the things that you've done in the past. So can you actually do that? But apart from that, in terms of hacking, like, sure, I mean, you can, people do a lot of research. They kind of take it from different repos and try experimenting that and all of that. That works as well. So typically the way I look at it is, like, you take, for example, we are doing something on speech recognition, right? It's a complicated area. So instead of kind of, digging through till the last level, you might as well pick up something. You actually reproduce the code and start playing with it, and then you start understanding the nuances. That's a pretty good hack, actually, if you think about it. Right?
Okay. And when they're actually working on these projects, right? Earlier in the session, you mentioned this personal recommendation kind of problem. If somebody goes to Google search and searches for a personal recommendation solution, there's lots of this on GitHub or Kaggle. What is the gap between one of these project solutions that you see on a GitHub and a Kaggle and a real live example? I assume the complexity of the data set is very different, but could you talk about that and what else is different?
I think the scale is the most, I think, is the biggest differentiator, right? Now, you could write a fantastic algorithm which on paper would give you, how do I say, the most accurate model, but it may actually not work in practice, because most of the times personalization is supposed to be done real time. I mean, not necessarily. not necessarily, but at least on the platform, people like, when you're coming on, you're doing certain things, you would want something to happen, right? I mean, some personalization to happen. Personalization, you can also obviously use it on your communication side, which means based on, what you've done on the website or the portal or your, digital activity, you could actually send something which is very personal and a great recommendation on your notification or a content, right? So that's also possible, but I'm talking about essentially the algorithm side where it's done real time. So that's where the scale comes in. You also need to look at the consideration of the platform that you're building, right? So how are you actually going to architect this entire solution? It comes down to that.
Understood.
Right? See, today, I mean, there's no dearth of actually algorithms out there. Like technically, you can actually use collaborative filtering. You can use some of the reinforcement learning techniques, which is new. So you can use all of that. But then, the difference between this and building an engineering system is very different. What is find on Google, which is a very small set of problems that you're trying to solve.
Understood. Okay. And just finally, the last question I had was, as you're trying to interview and onboard data scientists, one key thing you mentioned was things like understanding basic hygiene, things like coding, mathematics, problem solving, and a portfolio of projects. Is this portfolio the biggest thing that you don't see when you meet these people? I mean, what is the biggest obvious thing that you don't find in these interviews with these people?
So I think majority of the guys, what I've seen, and this is again, I think, coming to the skill sets of the people that appear to be, I mean, they're coming across as a data scientist, at least on the resume. And when I'm interviewing people, what I see is actually the basic knowledge. They don't necessarily have the basic. I mean, you need to. I expect the candidate to justify if he's actually done something. He needs to be able to justify why he's done something, and what's the logic, what's the math and the logic behind that algorithm. Right. I mean, to me, I think what's going on is, what I do see as a gap is there are multiple hundreds of courses out there and lots of information on the internet, like lots and lots, hundreds and thousands of these repos which are out there and resources. People, I mean, so you can essentially just kind of reproduce everything and do something, or you basically connect to different APIs and produce the result. But you should be able to justify why you've done that in the first place, which means people are not going deep. I think one of the things which I would find, I mean, which I would like to see at least, moving forward, is people are ready to think on a given problem and take it 10 layers deeper than what it actually is, right?
Right.
And that's the biggest thing that I find missing. Now, how do I overcome that? I think at least when I was young, and maybe I had the privilege of education of going through all the statistics, maths, and computer science courses. But the way I would actually approach this is like, when you actually work on something, why don't you read the theory behind it and get used to researching a bit, right? Like, what have people done apart from what you've just done, right? I mean, scikit-learn is not the only library out there, right? So I mean, in Python. So get to the go down, read a few research papers. That's a great skill actually to have, right? So yeah, I mean, that's essentially what I would expect in terms of.
Interesting. Go deep, ability to rationalize why you've done something. Dig into research papers. Okay. Yeah.
So first step, I mean, it's not very difficult, but people have to put their minds to it in some ways. So it's great. You are attending some courses. You are interested in data sciences, data engineering, whatever that. Data engineering is different. Data sciences requires that different level of thinking, which means it's not a deterministic world, right? I mean, where you may have hundreds of options. You need to figure out why the remaining 95 doesn't work, and 5 is what I'm going to basically trade off. So I think go through the courses, go through the fundamentals, be ready to go read a few research papers, understand what is going on. That will actually give you the cutting edge in terms of moving forward, at least.
Super. On that note, Thank you very much, Santosh. This has been super helpful. Some very good actionable takeaways right here.
Thank you, Binny, for inviting. I hope I can, be of some help to the students.
This has been very, very helpful. Thank you so much.
Thank you.